Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Multi-Agent Systems. When AIs collaborate to solve big problems. Imagine building a software system where different parts are smart and can talk to each other to solve a big problem. That's what we're diving into today. We're moving beyond the idea of a single, all-powerful AI and exploring how multiple AIs can collaborate like a well-oiled team to achieve incredible things. This lesson is about understanding how these AI teams work and why they're so powerful. Before we talk about teams, let's define a single player. Think of an AI agent as a small, smart piece of software designed to do a specific job. It's like a dedicated worker bee in a hive. It perceives its environment, what's happening around it, thinks, processes information, makes decisions based on its goals, and then acts, does something. From a developer's standpoint, you're essentially programming a mini brain with clear goals and rules for interacting with its surroundings, often focused on a narrow task. Why bother with teams when you could have one super smart AI? Imagine one chef trying to cook a 5-course meal, serve it, clean up, and manage the restaurant all by themselves. It gets overwhelmed, slow, and specific tasks might suffer. Similarly, a single, monolithic AI trying to do everything can get bogged down by complexity, become inefficient, and be prone to failure if any part breaks. As developers, we know that breaking down complex software into smaller, manageable modules often leads to better, more robust systems. Multi-agent systems apply this exact principle to AI. A multi-agent system, MAS, is simply a collection of these individual AI agents that work together, communicate, and coordinate their actions to achieve a larger, shared goal. Think of an orchestra. Each musician, agent, plays their instrument, performs their task, listens to others, communicates, and follows the conductor. Overall system goal: to create beautiful music, solve the problem. Here, you're not just coding one AI, you're designing how multiple AIs interact. This involves defining communication protocols, how they talk, coordination mechanisms, how they work together, and individual agent behaviors. Multi-agent systems aren't just a fancy concept. They bring significant advantages. 1. Tackling complexity. For really big problems, like managing a city's traffic or a complex supply chain, one AI can't handle it all. MAS breaks it down into manageable sub-problems. 2. Robustness and reliability. If one agent fails, others can often pick up the slack or reroute tasks, making the entire system more resilient, like a team where if one person is sick, others cover. 3. Flexibility and adaptability. It's easier to add new agents, remove old ones, or change existing behaviors without redoing the entire system. From a system design view, MAS offers modularity, fault tolerance, and scalability, key advantages for any complex software project. MAS are already solving problems in exciting ways. Traffic management. Each autonomous car could be an agent, trying to optimize its route and communicate with traffic lights. Other agents, to reduce jams in real time. Gaming. Non-player characters, NPCs, in sophisticated games sometimes act as agents, collaborating in battle strategies or resource gathering. Logistics and delivery. A fleet of delivery drones or autonomous vehicles could be agents, coordinating to deliver packages efficiently. avoiding conflicts and optimizing routes. Asterisk simulations. Modeling complex systems like economies, biological ecosystems, or disaster responses, where many entities interact dynamically. As a developer, understanding mass opens doors to building sophisticated simulations, intelligent game worlds, and highly automated, resilient industrial systems. As the developer, you become the architect of this intelligent team. Your job is to design the personality and skills of each agent, and more importantly, how they interact. This involves defining agent roles. What specific job does each agent have? Is it a planner, an executor, a communicator, or a sensor? Communication protocols. How do they talk to each other? Through direct messages, shared databases, or a central blackboard? Coordination mechanisms. How do they make sure they're not stepping on each other's toes or duplicating effort? Do they have a leader? Or do they self-organize based on shared goals? This involves choosing appropriate frameworks, designing APIs for inter-agent communication, and setting up environments where agents can perceive and act effectively. It's about orchestrating intelligence. Multi-agent systems are transforming how we approach complex problems, moving from single powerful AIs to sophisticated teams of intelligent software. This paradigm allows for more scalable, robust, and adaptable AI solutions across countless industries, from smart cities to personalized medicine. As you venture into AI, thinking about how AIs can collaborate will be a powerful tool in your developer toolkit, enabling you to build the next generation of intelligent systems that truly work together to solve the world's biggest challenges. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.